So this is module 25, where we'll be talking about retrieval of memories, which is also a little bit of a shorter one. I have to tell you I have a lot of problem with this these days. So recall is defined as some people through practice, visual strategies, or biological differences have the ability to store and recall thousands of words or digits, reproducing them years later. I mean, we all have some degree of recall. I have to tell you that as I age, my recall seems to be poor. I think part of it is because I don't practice as much anymore. Recognition: the average person can view 2,500 new faces and places, and then later can notice with 90% accuracy which ones they've seen before, which is kind of cool, really, when you think about it. 2,500 faces, and that we would recall 90% of them. Relearning: so some people are unable to form new memories, especially of episodes, although they would not recall. Some people are unable to form new memories, especially of episodes, although they would not recall a puzzle-solving lesson. They might still solve the puzzle faster each lesson. For example, it's kind of implicit versus explicit memory. And in the next module, we're going to be looking at some case studies where you can see how this transpires. So our storage and recall capacity is virtually unlimited. So if we're able to encode information and recall it accurately, there's kind of infinite amount of information that can be stored. But we know that our capacity for recognition is greater than our capacity for recall. So we can recognize things better than we can recall them. So because we are kind of cued for recognition. Relearning can highlight that the memories are there even if we can't recall forming them. Because I can sometimes see, that tip of the tongue phenomenon. You know that it's in your head, but you can't get it out. So what is this object? Even though it's obscured by 6 layers of scribble lines, those of you who glance in the corner of the first slide of the chapter may recognize this. So this is a cross-section of a tree stump. So a simple multiple choice question is also a recognition test. So you were able to kind of see the forest for the trees here, and you were able to notice that you saw it before. So how long does it relearning as a measure of retention? In the late 1800s, Hermann Ebbinghaus studied another measure of memory functioning. How much time does it take to relearn and regain mastery of material once you've already learned it once? So he studied the memorization of nonsense syllables THB, YOX, KVU, EHM, so that depth of processing or pre-learning would not be a factor. The more times he rehearsed out loud on day 1, the less time he needed to relearn, memorize the same letters on day 2. So you can see that as the number of repetitions increased, the time to relearn the list on day 2 decreased. And so basically he found that by regurgitating the information out loud, he was able to learn it, and then it took less time to relearn it in subsequent days. So retrieval cues. So memory is not stored as a file, as we learned in the previous module, and it's kind of stored all over our brain. And so we can't necessarily say, okay, I want to find this, and then kind of go in and pick up that file. It's not exactly how memory works. As we learned, memory is much more like a web of associations based on conceptual similarities, contextual similarities, and emotional similarities. So it involves a web of associated concepts. So sometimes, for example, just by having a smell or a first letter of a word, it can jog something, or by saying something else. So retrieval is affected by activating our associations, and this is known as priming. So priming triggers a thread of associations that brings us to a concept. So if you go back to that concept of the web, so by kind of highlighting one of those concepts, you might be able to then identify a bunch of others. For example, like a spider feels movement in a web, and it follows the movement to find the bug. Our minds work by having one idea trigger another, and this maintains a flow of thought. And it's kind of that, sometimes when you start, it then makes you think. For example, define the word bark. Now, what is the definition of the word bark? So how many of you, when you defined the word bark initially, defined it as the outside part of a tree? And how many of you defined it as the bark, like the noise that a dog makes? Well, you were primed in the first case because we had a picture of a tree to think about the tree bark. Now when you see a dog, you're primed to to think of the noise that a dog makes. So priming has been called invisible memory because it affects us unconsciously, so you were not necessarily aware. So in the case of the tree bark versus the dog bark, the path we follow in our thoughts can be challenged by priming. We may have biases and associations stored in memory that also influence our choices. So people primed with money-related words were less likely to help another person. Priming with the image of Santa Claus led kids to share more candy. People primed with a missing child poster then misinterpreted ambiguous adult-child interactions as kidnapping. So based on pictures that we see, it actually affects our behavior because it leads us to different paths. So kids who see Santa think about Christmas and knowing that they have to be good girls and boys, and therefore they're more likely to share, and that primed that kind of node for them. Context-dependent memory. Part of the web of associations of a memory is the context. So what else was going on at the time the memory was formed? So we retrieve a memory more easily when we learn in the same context as we form the memory. That's why they actually suggest sometimes studying in the classroom where you're going to have the exam, for example, because when you go into that room is going to trigger the information that you learned in there. So did you forget a psychology concept? Just sitting down and opening your book might bring the memory back. Words learned underwater are better retrieved underwater. So isn't that kind of cool? So when we had words that were learned in one context, so if you see the green bars and then recalled in a different context, the recall was only about 20%. But when it was in the same context, underwater or on land, we all got up to 30% for water and 40% for land. And these are statistically significant differences. So it's pretty cool. So our memories are not just linked to the external context in which we learn them, but they can also be tied to the emotional state in which we form them. So we have mood congruent memories. So has it ever happened to you that you're kind of feeling sad or down, and all of a sudden a lot of the hard times in your life kind of come to mind? But when you're feeling excited or happy, then you think about all the good times. So mood congruent memory refers to the tendency to selectively recall details that are consistent with one's current mood. This biased memory then reinforces our current mood. So recalling happy things when you're not in a good mood might be a way to increase your positive mood. Memories can even be linked to psychological states. So in this cartoon, I wonder if you'd mind giving me directions. I've never been sober in this part of town before. Interestingly, they found that, that's why people who have substance use problems have difficulties, remembering things in different situations because they learned them in an intoxicated state, for example. The serial position effect. Priming and context cues are not only factors which make memory retrieval selective. The serial position effect refers to the tendency when learning information in a long list to be more likely to recall the first items, the primacy effect, and the last items, the recency effect. So if I give you a list of 10 items, you're more likely going to be remembering the first two and the last two than the ones in the middle. So you can see on the graphs here that the words in the middle are not really very much recalled. The people are recalling the first words and the last words. So in which situation is the recency effect strongest? You can see that it is for immediate recall. That's the pinkish line. For later recall, we remember more the first words than the last words. But for the recency effect, remember how we learned about how you can kind of repeat the last few words that somebody says to you even if you're not paying attention, and that's why we see the immediate recall. So which words of your national anthem are easiest to recall? Well, for me, being Canadian, the first thing that comes to mind is